In this video, we will sketch the three rational functions given, f of x, g of x, and h of x, and then we'll identify the end behavior as well. So let's take a look at f of x first, and we want to sketch it. So we're going to first, well, actually, you know what? Let's ignore this, okay? I'm going to rewrite f of x equals, and I'm going to add 4 to the y value, because remember, f of x, that's the same thing as y. So normally when we start off, we're in the origin, right? 0, 0. Well, if I add 4, that means I'm going to increase my function up here to 4. And that's going to represent our horizontal asymptote. Okay, so normally we're at y equals 0. That horizontal asymptote would be going right through there, but we're going to increase our function by 4, so it gets shifted up 4. Okay, well, let's go back. Let's get rid of all that erasing, and I'm going to think about what x value would create a 0 in the denominator, because if we ever have a 0 in the denominator like this, if we had 1 divided by 0, it would be undefined. Our function, it cannot happen, right? You cannot divide by 0. So what would I plug in for x that would create a 0? And that would be -3. So if I say x equals -3, right, and then we're going to add 3 in the bottom, you would have a 0 in the denominator, and we cannot have that, right? So I'm going to graph this dashed line here that runs right through x equals -3, because we know when we graph our rational function, we can't go over that at all. There's going to be a gap. It's discontinuous. So now I'm going to go ahead and graph my rational function. We're just sketching it, so it doesn't have to be perfect here. Let me redo that one. That could be a little bit better. So when we curve up right here, it cannot cross over that vertical asymptote, that green dashed line, because it's just undefined at x equals -3. And then we're going to curve it over here, and we're not going to cross over that horizontal asymptote either, right? So that's going to be the beginning of the rational function. And then you could mirror it across where the asymptotes intersect, and as we curve down here, it's never going to cross the green one. It's just going to approach it, and then same thing with this red one right here with the other asymptote. So you could kind of start with an L shape in the top right hand corner there, and then it'll get mirrored over, you know, across diagonally, and then be in that little location there. So that would be a really rough sketch of the rational function. So now let's take a look at g of x. So g of x doesn't have anything happening out here. We're not adding, we're not subtracting, so we're going to keep that horizontal asymptote going right through y equals 0. Okay, it's going to be right on top of the x-axis. So then we could take a look at the denominator, and remember, we cannot divide by 0, right? So what x value, if we plugged it in, would create a 0 in the bottom, and that would be 2. If you said x equals 2, and then we subtracted 2 from it, that would give us 0. So there's going to be a vertical asymptote when x equals a +2. So I'm going to put that dashed line in there, and that's going to represent the vertical asymptote. So our graph will never touch that. So I'm going to curve it. It's going to approach that x equals 2, but it never gets there, and then it's going to approach that horizontal asymptote as well. And then we want to flip it over here, and then we'll be left with that. So again, just a very rough sketch, the shape of that rational function. That's what it's going to look like. Okay, and last but not least, I'm taking a look at the outside here, and we are subtracting 5 from the function. So from y equals 0 here, we're going to shift it down 5 because we're subtracting 5. So I'm going to put in a dashed line here to represent the horizontal asymptote. And then I know that I could plug in just the 0 itself right here, x equals 0, and that would create a 0 in the bottom, so x would be equal to 0. Our vertical asymptote is going to go right through our y-axis, just like that. And then you could add in the rational function, the curve itself. So go ahead and fit it in the top right hand corner like that, and then we'll put it in like that as well. Again, this is not perfect, not super accurate. We're just looking for a general sketch, you know, something that will take the shape of that rational function. So now, if you want to go back and get the end behavior, we could do that. So let's go ahead and just start with what we have here. I'm going to write as x goes towards positive infinity. So that means like as we are increasing this way, h of x, or the y values, will approach what y? Is there a y value that we are going towards? And then in case we are, okay, or in this case we are, we're going to curve down as we get further and further to the right as our x values approach positive infinity. That blue curve there is going to be approaching the horizontal asymptote, which we said was y equals -5. So I'm going to go ahead and add in -5 there. And then I'm going to write the other side as x goes towards negative infinity. The h of x, or our y values, will also be approaching -5. And I'm going to just kind of look at this way. As x's approach negative infinity, as we look at the left side of a graph, we're going towards y equals, well, the -5 for y values. And then for g of x, I'm going to go ahead and write as x's approach positive infinity, g of x, our y values approach, again, our horizontal asymptote. In this case, it was 0, so we're going to put in 0 there. And then as x's approach negative infinity, so this is going to be the left side of our graph, g of x, our y values, again, will approach that horizontal asymptote, which is 0. It's always going to be that same value, the horizontal asymptote. And then last but not least, that first function we graphed, f of x, I'm going to write as x approaches positive infinity, f of x, our y values, are approaching the horizontal asymptote, which was 4 in this case. And then last but not least, as x's approach negative infinity, or the left side of our graph, f of x, or the y values, will approach a 4 as well.